Um, I'm Ron. This is the workshop called Flying Under the Radar. Um, yeah, I'll start by talking a bit about myself, and a bit about the workshop. I have a lot of content to go through, so I'll probably go to the slides real quick and get you to the exercises. Um, yeah, my name's Ron. I work at Grey Noise. My job, I work in a labs team, which is part of research. We basically, at Grey Noise, we identify, like, we run honeypots, and anything that hit the honeypots, we identify what it is. Part of my job is to, like, write the rules to identify traffic. This is the CV, this is that CV, this is path traversal, this is SQL injection, all that sort of stuff. I write blogs there. My biggest job there is I call troublemaking. I find problems and then make people fix them and annoy everyone. And this workshop sort of came from some of that, like, troublemaking. Basically, we have thousands of zero car rules that we write to, like, track malicious traffic. And I started getting really annoyed that we'd missed a lot of things because we write rules that were overly specific. So I started collecting sort of examples. I think I changed tabs, but I have a big list of stuff that was bothering me, and I ended up submitting a 30-minute talk about it. And I'm like, I can't do this in 30 minutes. So I decided to make it like an interactive workshop and just make you all do what I do for a while. I write CTFs in my spare time. I'm the, like, lead CTF dev for B-Side San Francisco, which is kind of cool. I always have to say I have two pet birds. That's Clang on the top and Sharp on the bottom. Sharp learned he can roll over for treats and now won't stop rolling over on my desk. And, like, when I'm not doing, like, researchy computer stuff, I play computer games, Dungeons and Dragons. I've been doing improv classes for the last year and a half. So the improv classes have sort of taught me how to, like, talk in front of an audience without knowing what I'm talking about, which, welcome to my workshop. I love magic. I don't do magic. I just love magic, and I have lots of weird hobbies. So this is the first time running this workshop. I put a lot of time into writing exercises, stuff like that. The general flow is going to be kind of three parts, which are going to sort of intermingle. First, we're going to do some exploit dev. I'm going to teach a few simple exploits against CTF challenges. We'll do path traversal, shell injection, SQL injection, XXE, a bunch of other stuff. And we're going to write exploits for that. Kind of pop shells, not really. Usually print files. These were all originally capture the flag challenges that I wrote. Then we're going to write zero cause signatures to detect those exploits. And we'll learn the basics of how to write zero cause rule. If you already know how, then it's going to be a review. And then we're going to go back and forth, do a few more exploits, a few more rules. And then at the end, I have about 30 to 40 basically zero cause rules I wrote to detect the first section of exploits. And we're going to learn how to bypass those rules by using, like, HTML encoding or, like, mangling paths or a whole bunch of stuff. Whoops. I originally wrote this as like a 3-hour workshop, and now I have 2 hours, so I'm going to move fast. So as I said, like, this kind of came from lifting rocks at Grey Noise. We started doing code reviews on signatures, and I started having problems with signatures, like, this can be bypassed, blah, blah, blah. So I wrote a linter. I started, like, being really firm in code, not firm, but, like, really fussy in code reviews and making people fix things. So that's what this kind of came from. I already covered the flow. So everything we're doing is going to be in the browser. I wrote an app that's all browser based. It's written in Ruby because all I know is Ruby. And when we actually get the exercises, I will put up the URL and stuff like that. All the infrastructure is real. I have 3 different servers that you can choose from. If one breaks, there's 2 more. Hopefully they'll all be fine. The absolute worst case, I have a GitHub repo I can make you download and run in Docker, but I really hope we don't have to do that because that'll take like a half hour to set up. We don't have a ton of time, so I'm going to move really quick through the exercises. If you aren't sure about something or it's really boring, like, I don't care about SQL injection, you can just use a skip button and, like, go on to the next stuff. Yeah, there's 10 challenges. I already said that I wrote them for a CTF. The theme of the CTF was there be dragons, so you're going to see a lot of dragon theming for no reason. So don't worry about the dragons. I'll just show you the UI quickly. I'll show you what it's going to look like. Then we're going to talk about HTTP for a bit, and then I will let you loose on some exploits. So this is what it's going to look like. I'll zoom in a little bit. Too much. Unzoom, unzoom. There we go. So you have a list of levels on the left. Each level is basically going to have, there's going to be a little bit of narrative. I'm going to cover all the stuff you see here in slides, so you don't have to read all this if you don't want to. But basically, on the left, you'll see requests. On the right, you'll see the responses. The servers are all hard-coded. You don't have to worry about what server is hitting. It's hitting the server for the challenge. You click send, it will print out the response. Simple as that. You can add headers if you want, like cookie, blah, blah, blah. You can do whatever you want. The one thing I'll caution you, I put a checkbox down here, don't fix my requests. There's a few things you need, like the host. If you don't put the host and you don't click this button, and you check this button, you're gonna get bad request. So I did my best to fix, if you do things that are gonna break HTTP, I try to fix it in your request. So just a word of warning. This is what the exploit levels will look like. This is gonna say, this is gonna be a shell injection vulnerability. Here's the vulnerable code, some info of the exploit. Once again, this is all gonna be covered in slides. You don't have to like read all this. It's just for if you do it later or whatever. And I'm gonna give you the base request and you're gonna like do the exploit basically. So that's the idea. So before I actually set you loose on this, let's talk about HTTP and let's talk about like the first 3 exploits that we're gonna look at. So this is like I gauge this as like a medium difficulty workshop, so I think you'll probably have an idea of how HTTP works. But just in case you don't, I'll cover the basics. This is what GET request looks like. This is the first thing you'll have to match when you write circuit rules later. There's a method, which is get or post. There's a URI, which is in this case backdoor PHP. There's a version. Don't have to worry about the version. Then there's headers. There's in this one, there's a cookie, there's a host. Some of the challenges will have different headers. It all depends. Sometimes there'll be arguments. So in this, this is get, method still get. The URI this time is picture.php. And then this one is an argument, file equals upload / dragon1.jpg. As I said, you're going to see weird dragon theming. And then the headers for this one are just the one host, localhost. Post request, very similar. The thing about post requests is they require a content type and a content length to work. The tooling will add this for you. You don't have to type this yourself. And typically, if you're already doing a get or post request, you'll know which one. So like this is a post request. If you want to do get, you can switch to get. You can move the parameters, stuff like that. For the bypass levels, this will be more important. This is going to break because we don't want this stuff anymore. Yeah. So like there's get requests, there's post requests. I'm sure you're aware of that. All right. The thing to note is how arguments are passed, and this will matter a lot. So you'll see here, like file.php. I wrote multis in PHP because PHP is really easy to write vulnerable code in, it turns out. If you see arg equals ABC, you can do arg equals %41, %42, %43. That's called URL encoding. If you're not familiar, you can Google it, and you'll need it later on. These are what headers look like. Headers are name, colon, value. There's headers that are required, like these ones, the host, content type, content length. There's optional headers, there's cookie, there's other stuff like that. If you need to use them in a challenge, I'll tell you. These aren't supposed to be hard challenges. The challenge is to write the exploit, not to like find the vulnerability. So I'm going to be telling you at each point what you're going to be doing. Post arguments are like get arguments, except the arguments go in the body, not the URL. The thing to note when you're writing a circuit rule is that when you do %41 in the post, it doesn't decode them by default. You have to decode them manually. So when you're bypassing a circuit rule, think about that. My meeting will end in 10 minutes. I'm supposed to contact IT. Help. This seems like a problem that will come up again in 10 minutes. We'll see. We'll see what happens in 10 minutes. I already gave you a demo. Right, so that's the basics of HTTP. And like I said, I'm moving quick. Each of the challenges will tell you what to do. So hopefully you'll be able to keep up. So for the first section, we're going to do 3 different exploits. We're going to do a shell command injection, a path traversal, and a default login. A default login just means encoding credentials. It's not like you have to find anything. So shell command injection basically occurs when the when a program calls a system function or a similar function with an executable and includes a attacker input. If they include attacker input with no escaping, you can inject in a variety of ways. You can use semicolons, backticks, pipes, ampersands, new lines, blah, 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 $sign brackets. It's up to Bash how Bash interprets your commands, and it turns out Bash accepts a lot of different commands. The one that often gets forgotten is new lines. A ton of rules that I've written, I completely forget that new lines can be used for shell injection. That's another hint for the bypass section later. The other thing about new lines is in Suricata, if you use the regex, regexes don't cross new lines by default. So if you use a new line and you try to use a regex to match it, it won't. And that's another hint for later. Um, Path traversal, like I said, I'm moving fast because limited time. Path traversals is basically adding dot dot to the path. I'm sure you've seen this before. The thing I want to point out here is the second one, which path traversals aren't necessarily just dot dot slash dot dot slash dot dot slash. They could be dot dot slash dot slash dot dot slash dot. You can usually use multiple slashes. You can sometimes use backslashes. Um, you can of course encode things. Periods are %2e, slashes are %2f. That will usually work depending on where it's going. And like that's the basics there. And then the last thing before I set you loose to do those three things is default logins. In this case, I'm going to tell you the login. It's going to be admin admin. And you're going to need to add an authorization header, which contains the word literally basic, which is for HTTP basic auth. And then the username colon password in base64. I give an example here in Linux. Username colon password in base64 is dxn blah 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 blah. So that's what that would look like. The little new line you can ignore. So if you need to encode this, you can use CyberChef or like some online service. It's not hard to find a base64 encoder. So that's pretty much the like quick intro. Um, the first few challenges, that's the QR code. I'll put it back in a second. The first, oh, the other thing to note, there's a skip button. I'm pointing at my screen because I forgot what I'm doing. There's a skip button here. You can skip any challenge you want, and it will just open the next challenge. So you don't have to do everything if you don't want to. The big secret that might be in my notes, I forget, is if you open your browser console, type unlock underscore all, that will unlock everything. So if you want to skip everything, you can see everything that's available. So the way it's going to work is that each of the headers, exploitation part 1 will be the first exercises, Suricon part 1 will be the next one, then exploitation part 2, Suricon part 2, etc. Between each of them, I will go through and give you the solutions to the previous ones. So I will walk you through each one. So this QR code is the same one. It will link you to this doc. The doc has Wi-Fi, a couple quick rules, which is basically don't break stuff because, you can break things for other players and that's mean. Don't do a fork bomb. Don't like do an infinite loop, please. If anything goes wrong, flag me down. There are 3 different servers below. Just pick one at random. Like they're called 1, 2, and 3. There's also SSL version, which is just using a SOCAT relay. I am not an infrastructure person, and my friend who was going to help me and then couldn't. So, just use my HTTP. Yeah, I'll give about 10 minutes for this. We'll like work until about 20 after, and then I will cover my solutions, and then we'll talk Suricata. Any questions? I know that was really fast, but everyone good to go? Sweet. And the URL is just, if you don't want to do a QR code, this is the URL right here. 3 minutes ahead of schedule. That's good. My schedule lasts 2.5 hours, so I need to save time. If you have any questions or can't get something working, just flag me down. I'm here for you guys all day or for 2 hours. I'll also mention I'm gonna leave these up online over the weekend, so if you can't get things done and want to come back, I'll shut them down like Monday, Tuesday. So give a few days. Cool. We have time right now if you want to do that. My boss is watching live screen. No pressure. Everything good on your end? Cool. Good on your end? All right, we should go over the solutions to that one and then carry on with ranks for color rules. So the first one getting started is going to be like click on send request. So not much of a solution for that one. So for the shell injection, I sort of showed you earlier. I'm going to reset this back to the default. So this one, there's a lot of different ways to solve it, but like, I'll just use who am I as an example. You semicolon command will work. Backticks command will work. There's a bunch of different commands that will that will work. Stuff like that. That will work. I think backticks will have the problem where they just do the first line. So like, if you are going to use backticks, you'll keep that in mind. I believe a pipe will work. There's a bunch of different ways you can solve this one. And for the bypass challenges, you'll need to use some of those. So I will just copy and paste the correct thing. I sort of made fun of the AI with this, as I like doing. So that's that level. Path traversal. This is just a path traversal in the URL, so /// whatever. As I mentioned, you can use single dots, you can use multiple slashes, you can do a lot of fun stuff with it, and it'll all just work. In this case, this is a file to access. So there you go. That's the path traversal. Then default login. For this one, all you need to do is figure out the authorization header, which is base64. See basic, and then I'll just use the command line. Echo admin base64. Copy paste, send. There you go. So the thing about base64 is just mutable, and that will come up later, where if you change 4 to 5, you might get the same password. We'll talk about it after, but that's going to be that's going to come up later. And then another path traversal. I forgot this was part of this section of challenges, but this is the previous one was in the URI, so you know // This one's in a parameter, so this one's file equals, and it's gonna otherwise be the same. So // whatever, and copy paste send. There you go. The thing I mentioned earlier, you can encode things. So %2e instead of a dot. You can do %2f instead of a slash. HTML encoding is your friend when you're bypassing. So there you go. And that is the exploitation rules. The next section is going to be suricata. I'm going to write down my timing just for future reference. Cool. All right, we're going to talk writing suricata rules. My job is a little bit weird because when I write suricata, I'm doing largely unsolicited traffic where we deploy a honeypot and people send us exploits, but it's not in line, so we're not blocking and stuff like that. So it's a little bit different from how a lot of you would probably use suricata, but we're going to kind of learn it from my perspective. So suricata, if you're not familiar, is a tool for matching packet data. You write suricata rules, you feed in the PCAP or a network socket, or not socket, a network device, and it will tell you what matches a rule and what doesn't. You can use those inline to block or alert. In our case, we're just going to do alerting. We're not going to do blocking. And I'll tell you, in the app, we're kind of faking it. In this game, when I write suricata rule, I am taking your rule, writing it to a file, running it on a, making the request and stuff into a PCAP and running the file on the PCAP. So this isn't actually network stuff, it's PCAP based. It's all very magical, and I'm very proud of all that nonsense. So this is the basic structure of a rule. When you write rules for this workshop, they're all going to look like this. It's going to be alert. We're only doing HTTP, any arrow, any. Those can be used to match hosts and ports. It doesn't matter for us. This is all fake. So any will work for everything. And then there's going to be parentheses, and within the parentheses, there's rules and metadata. What are those rules and metadata? They are, first of all, the only mandatory one is a SID. The SID is the identifier for the rule, and it can be any numeric value. The trick to SIDs is they have to be globally unique. So if you run 1,000 rules, all 1,000 rules have to have different SIDs. If you think that sounds annoying to do that as a company, it is. The number of times we've checked in 2 rules with the same SID is so high that we had to write tooling to make sure we don't, because it's very, very easy to mess this up. I asked other people like Volncheck who write suricata rules, how do you do it? And they said, same as you. We have GitHub checks and stuff, but yeah. This is just a beef. I hate SIDs, but it is what it is. These fields don't matter that much, but the other fields you'll commonly see is a message, which is what gets printed in logs. For us, doesn't matter what it is. They flow, which is how you're matching it. We're going to do flow to server established, which means there's an established TCP connection, and it is from the client to the server. Once again, all of our stuff will be in that state. The flow doesn't really matter. And then the revision is how many times the rule's been changed. I just mentioned these because if you're writing suricata rules in the real world, you'll see these a ton. For us, doesn't matter. Just use the defaults. Doesn't matter. Just and then outside of the metadata, you're going to see a bunch of, you're going to write a bunch of matches basically on buffers. A buffer is like http.uri or http.method or http.header or http.cookie or http content type or http request body. Those are buffers. You can modify the buffer. You can use no case, which is case insensitive. You can use URL decode, which will take %41 and change it to A. We'll talk about that after. Content is a literal string. This says, does the most recently mentioned buffer, in this case HTTP contain the literal string ABC, yes or no? If it does, it matches. If it doesn't, it doesn't match. If it does, it matches. Then you can modify the matches with starts with, ends with, stuff like that. So in this case, up to the starts with, we're taking the URI, case insensitive, decoding it, which actually doesn't make sense because URI is already decoded. Does it contain ABC? Does it start with ABC? And then PCRE is a Perl compatible regular expression. In this case, I did A.B, which is A any character B. If you don't know regex is, you can Google how to write regex. And then the I is case insensitive. When you're doing a content match, you need no case. When you're doing a PCRE match, you need /I. That's just how it is. I also realized I wrote this rule wrong. The no case should actually be after. I know how to write Suricata. That's better. Real-time fixing rules. That's my life. All right. So this is a list of all of the keywords you'll need for the exercises. There's a big list on Suricata. There's a huge list of stuff you can match against. Suricata's documentation is extensive. We only need a very small slice of it, so I'm not going to make you read all this stuff. But if you want to reference it, this is it. Be sure we're using Suricata 708. If you Google Suricata documentation, you'll find latest. Latest and 708 are very similar, but there's some differences. So just be careful with that. If you're getting an error, that's probably why. All right. So normalization is a thing that will matter more in the bypass section. But when you use the buffer http.uri, it is normalized. What normalized means is ... slashes are resolved. So my /path/... becomes my / the next thing. It will interpret the URI and fix paths. It will also URL decode. So %41 becomes A. So that will happen automatically in http.uri. The trick there is if you're trying to match a path traversal like A/./B, that won't work because it gets normalized. You will instead have to use http.uri raw, which does not normalize. So those two buffers, why they're different kind of matters. And when I was first learning Suricata, this got me a few times because we didn't know what the difference was. And then we learned. So that will be one thing to kind of watch out for. In the path traversal challenges, in the URI path traversal, you'll need to use raw. In the argument path traversal, you can use raw or normal. I recommend normal unless you need raw. The other handy keywords, URL decode for buffers that aren't decoded by default, like raw or request body. You'll have to use URL decode manually. Base64 decode also exists. It's a real annoyance to use. You can Google how to use it, but it's a pain in the butt. So I recommend not worrying about that too much. So then you can use content, you can use PCRE, and you can use no case starts with ends with. That's all you should need. And as before, in each challenge, I will tell you what you have to do. You don't have to figure out too much. The other gotcha is if you have to match something in content that is causing you problems, like a semicolon or a pipe, you can use pipes to use hex. So pipe 6.1 pipe is lowercase a, pipe 6.2 pipe is lowercase b, and so on. If you have any problems with matches, you can use the hex encoding. I always suggest don't use this unless you have to, because obviously it's harder to read and maintain. I have a section for UI demo, but I haven't shown you this one yet. Let me show you the URI, the UI for this. So I kind of give the same information on these pages once again. The first challenge is write a valid rule, and a valid rule is copy, paste, test. And this is just to teach you how to use the UI. I think I didn't mention is if there's problems, things that match and things that don't match, you can mouse over and click, and it will show you which one is causing problems. That'll be useful in the later levels where I give you here's 2 evil requests and here's 2 good requests. The challenge is to match the bad requests without matching the good requests. So for the first one, if you were to do http.uri content backdoor.php and click test, what you're going to see is yes, it matches the evil payload. Yes, it matches the other evil payload. It did not match the first good payload, but it did match the other good payload, and that's bad. So you have to make sure you figure out what's different. In this case, it's the cookie, and then match that. So in this case, I'll just give you the solution to the first challenge, which is http.cookie semicolon content ABC equals 1, 2, 3 content 1, 2, 3 1, 2, 3, and that's that. So what you're seeing here is we're gonna and that's that. This stuff does what you're seeing here is we're gonna the message and flow don't really matter. I think you can even just delete them and it's fine. Don't really matter. I think it's all good. Delete them and it's fine. So we're switching to the HTTP URI buffer. So we're matching the string backdoor PHP. We got no case here if we wanted to. Doesn't matter. Then we're gonna switch to the cookie buffer, and then we're gonna match the other content, and that's two different match rules. For a rule to pass, they all have to match. So there's no or, they're all and. So in this case, the URI contains backdoor to PHP. The cookie contains ABC123. That's what this rule says. And that's basically it. There's 1, 2, 3, 4, 5, 6 different challenges here. I'll give you about 10 more minutes. We'll come back at 10:42, and I will put up the connection info again. I'll do it here. There we go. So yeah, about 10 minutes, write some rules. If you have any questions, flag me down. Happy to help. If there's an error in your rule, it will tell you what the error is. It's Surikata's error output, which is very hard to interpret, but I can usually see the rule. I can usually see the problem. So if you're finding a stupid error, just let me know and I will help. So if you're finding a stupid error, have fun. Let me know and I will help. Yeah, have fun. Excellent. I want to add like more interaction time to have people tell me their solutions, but I realize with the time limit I have, I don't think I can do that. So I think I could run this as a half day, honestly, like a 4-hour thing, maybe even a full day. But that's okay. Yeah. It's like I have not enough content until I have too much content. I have content. I think my next exercise is gonna blaze through. It's like SQL injection, path traversal, SQL injection, another kind of shell injection, one other. I'm just gonna like boom, boom, boom through it. Like catch up. This is the fun part anyway. Working on things. Fun part anyway. Working on things. Also, there's a Zoom echo about 3 seconds behind. Are we typing audio? I don't know why that would happen, but I don't know why. He said it wasn't happening at first. Should make sure. And my audio's off. My audio's off. It sounds like it's starting to be upgraded. Yeah. I let them know. I know. I was being so sneaky. Hi, internet. It's 6 viewers. All right, I think I'll cover some solutions now. All right, so I already did the first couple, but I'll do them again real quick. The first one, like I said, you just copy and paste the rule. The only point is to show you what a rule looks like. Make sure that you have like a working rule and that the you know how to use the UI. So the next one, we want to match the backdoor and the cookie. So like I said, we use HTTP URI content backdoor. So it will also work if you do URI raw, like I said, but that is much easier to bypass. So that will be a thing to look for later. Shell injection. There's lots of ways to solve levels like this, honestly. But like what we're looking for is IP equals and then a semicolon, or IP equals and then a pipe, or IP equals and then a backtick. But we don't want to match IP equals and none of the above. And we don't want to match an empty request or get request. I would want to match an empty request. So there's actually two. I'll show you two different ways to solve this one because it might be helpful later. You can do you can mesh a method here, issue method, content post. You don't have to. If you're writing rules in the real world, you'll want to narrow it down just for efficiency. It's faster if you match like a post, but you don't have to. We want HTTP content detect dragon.php HTTP request body. A habit I've always formed is if you're doing a request body, you always add URL decode. Otherwise, %41s will get you. If you see rules in the bypass section that don't have URL decode, that's a big hint. And then you can do content colon. You can do content. Let's do just semicolon for now. That's going to miss some. Content just semicolon. Test rule. What you'll see is you'll detect the first one, not the second, not the third. So in this game, what you can do is copy and paste and just do 3 separate rules. That's the like, I won't say cheating, but that's not really the intended way to do it. And each of these rules detects one of them. That is absolutely fine, and you can do that. Pipes are annoying. I always forget. Pipe is 7C. I always forget. You can't match pipes and contents. You have to do it like that. And that will complete the level. And that will work just fine. But if you want to do it all in one rule, you can use a regex. So let's delete the extra rules. And then in the body, instead of content, we will use PCRE. PCRE looks like this. You usually want to do case insensitive, and you usually want to do multi-line because it is possible to use new lines for these exploits. And like I said, so IP equals dot star, and then we need semicolon, pipe, and backtick. And you have to skip semicolons, of course. I was just testing you. And that is one way to do it. You want to do new lines as well. I'm not even sure if it works like this, but this will detect the things I want you to detect, so that's fine. So next level is going to be the path traversal. So first I will show you the way that doesn't work, which is HTTP URI content .. Obviously, in like a real rule base, this is going to match a ton of stuff that's not this exact exploit, but that's fine. Like that's what we're doing for a workshop. So if we do this, it's going to fail. It took me a really long time to realize why this didn't work when I was first learning Storycada, because we wrote a lot of rules without testing them, and then a bunch of rules for path traversal started failing, and I'm like, why does this not work? It's right there. The trick is .raw. Now that will work, but if this was %2e, that will fail because the %2es are not decoded. So if you're using raw, you always want to do URL decode, unless you need to match the % stuff. URL decode. So always remember URL decode if you're using raw, unless you have to match the %. If the exploit is %2e, then like you don't URL decode. But yeah, URL decode is your friend always. Then default login, we're going to do the really lazy way of doing it, which is HTTP.header content base 64. Uh-oh. What did you? Oh, semicolon missing. All right. And that's the simple way to solve it. the hard way. All right. Do I have in my notes? That's the simple way to solve it. I have notes I'm not using. Do I have in my notes? I have notes. No, that's how I solved in my notes. You can use base64 underscore decode, and in the bypass levels, you will see that. Base64 underscore decode. But we're not gonna worry about that. All right, path reversal in parameter. This is going to be just like the URI one, except you don't have to use raw. This is going to be so HTTP URI content, picture.php, content dot slash, semicolon, and that will pretty much everything. And this is sort of demonstrate that HTTP URI will get decoded. So dot 2e 2e 2f will match dot slash in URI. If you use raw, it will not match. And I say this over and over again because this is where a lot of problems in SOGAR rules happen, is using the raw buffers. Raw buffers are really hard to use correctly. So there you go. Raw buffers are and like the normalization happens in the URI part, not in the parameters. And that's why the two different path traversal levels are a little bit different. That's why the two different I think I did one bonus level and I wanted to demonstrate how to do the body. One bonus level. This is to actually demonstrate exactly what I was talking about raw buffers. So you can do HTTP URI, content, picture.php, http.request body, content dot slash. This is exactly how we match the URI, except this will not work because request body is not decoded. If you stick a URL decode in there, now it'll work. URL decode in there. And I harp on this and say it over and over again because this is a mistake that I've made so many times, that we wrote a linter for Suricata to tell us if we do this. So that is the end of the Suricata section. I'm gonna write down the time. 48. Cool. So for the next section, we're gonna do some more exploitation. Woo! So for the next exploitation part 2. I'm gonna go to the slides real fast and give you time to do the hands-on stuff because our time is limited. So we're just gonna talk about a couple different exploit types. First is SQL injection. You will typically see this payload that's in red in the middle, blah blah blah, quote or 1 equals 1. The point of that exact syntax is to not break the query. So as you can see in the bottom red, the query, all the quotes are balanced and it's still a valid query, even though you're injecting SQL. That is one option. The other option is to use a comment. Dash will comment it. If you don't balance quotes, or if you can't balance quotes in the SQL query, you can use hyphen at the end to just comment out the rest. If it matters, the exercises we're going to do are on SQLite. I don't think it matters, but if you want to use special syntax, they were all SQLite databases. If you want to use special syntax. The next one is shell injection. Again, this shell injection is a bit more difficult. It's going to be in a JSON payload. And if you cause an error, it's going to fail and not show you the output. So you're going to have to do a similar thing to the quote or 1 equals 1 quote thing to make sure, to this one rather, to make sure you don't break the command. This one, I'll tell you, is a pain in the butt. It took me a little while to write the exploit for it. So if you can't get through the shell injection, don't worry about it, just skip it. The last one is XXE, XML external entities. XXE happens, I don't even have a demo. XXE happens when an XML parser parses arbitrary XML and uses insecure settings. My advice on how to exploit XXE is Google XXE exploit. Click on Portswigger or similar. Find their exploit like this and then use it because that will just work on the challenge. So that should be a pretty simple one to solve. The only hard one's probably going to be the SQL injection and the shell injection. And that is pretty much it for lecture. I want to keep that part real short. I'm sure it's fine. So that will be that. It is 10:50. I'll give you like 10 minutes or so and we'll start back at about 11. I'll give you like 10 minutes or so. As usual, feel free to work ahead of stuff if you want. This isn't like strictly segmented. Feel free to work ahead of stuff if you want. And yeah, have fun. This isn't like strictly segmented. Yeah, have fun. I'll also mention for the next section, my slides on Circuit Part 2 are just do the exercises. So if you finish the exploitation, feel free to just work on Suricata. I have no new slides for Suricata. Eight viewers. No less. Good. Everyone's streamers can see how I work my laptop. Yeah, everything's muted. Mute, mute, mute. Yeah, everything's me on my laptop. See, mute, mute. Test, test. All right. Um, let's cover the solutions to the explanation part one. Then we'll go straight into explanation part two. Then we'll go jump straight into circular part two with no further slides. All right, so the first one is a classic SQL injection bypass password. If you put a single quote in the password, you will see a SQL error, and you will show the exact SQL query. So you can see that there's no escaping, nothing like that in the password. There's a lot of ways you can exploit this, but the classic way is or 1 = 1. As I said, you can do that, or you can use a comment. Those will both work just fine. Something to note for later too is you don't need spaces. Spaces are completely optional. So, keep that in mind. Right. Next level is going to be a different SQL injection. This one's going to be a more of a pain to exploit because it has parentheses and stuff. So you'll see like this has, when you put a single quote in, it's going to put the quote in 4 different places, which makes it really, really, really hard to balance it if it's even possible. So you can do the same thing as this one, or one. I should have mentioned too, you have to URL encode this. So or 1 = 1, balance the parentheses, dash, dash. I have a solution in front of me, so if this doesn't work, yeah. So what we're basically doing is adding or 1 = 1, then we're balancing the undo. We're balancing the parentheses. If we don't balance the parentheses, you'll get an error because you'll see or 1 = 1. This is the full query right here. And obviously this is an invalid query because there's an open parenthesis, but no closed parentheses. So that's what that's for. You can also put it here. It doesn't actually matter where it is. What's also neat is instead of plus, you can do %20. Those are equivalent. Once again, lots of stuff is mangleable. You can change things without breaking it in HTTP, and that's kind of a cool thing that makes it easier to exploit. I think also you probably don't need spaces here at all. Do you? Maybe you do. Yeah, you do. All right. All right. Next level. This level I ended up kind of hating, but I gave you this snippet PHP code, and what you'll see there is if horde type equals artifact, execute it, and put gold, gems, and artifacts all in the shell exec in the command. So the first thing to do is change horde type to artifact. You send the request, and you're gonna see like success, blah 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 blah. If you stick a single quote in, just like before, we are now escaping. We are now trying to escape from the quoted command, just like this. So what you're doing is you're sticking a quote inside this field, and now you have an unbalanced number of quotes. So that causes a an error, and now you'll see command failed /apps evaluate horde 10 quote quote. So now you can use a shell command. I'll just use who am I as a demo. And I found I struggled to get the command to actually work without actually balancing, without actually making it work properly. So I just do echo, which just fixes the command basically. And that should basically work. Sorry, I meant to semicolon. And that should work and print out the command, the user. If you don't do the echo, I'm pretty sure this will fail. And it drove me crazy trying to like troubleshoot that. But a comment down the end, that works too. Perfect. Uh, Send request. Yep, there you go. Love it. That's way easier. Um, now I'll just have to print the right file, which is this. Usually I just use cat etsy password for most challenges, but I thought it was fun to like make you cat a different file just for like just to see something different. So that is that solution. And the last one, XXE, I pretty much told you how to solve that one. Copy somebody else's exploit, uh, paste it, and there you go. Ooh. The thing to learn about this one is the previous stuff we've done have used URL encoding or HTTP URL encoder, or whatever it's called. This one uses multi-part /form data, which is a little bit different. And the thing to note about multi-part form data is this is when you upload a file typically. It's like a file upload style form. You will see boundary equals blah, blah, blah. And then you'll see that boundary. This wraps because of my small font, but if it was smaller, you'd see it. So it'll have like the boundary, a parameter, the boundary, another parameter, the boundary, another parameter, and then end with a boundary. I've written a lot of rules initially that were matching the literal string WebKit boundary, and that will not work because this is completely freeform. You can make this whatever you want, and it will still work as long as it's between all your requests. So don't ever match on the boundary, match on the content type and on the file name, the name field. So again, hints for the bypass section. And then, yeah, now we're gonna move on to the Sirikata section. As I said, I have no slides for this. It's the exact same Sirikata we're doing before. There's nothing new. It's just matching different things. Uh, because of a question I got, I will mention as well that where'd it go? When you're trying to match something like this, you can use a PCRE. I'll zoom in again. A PCRE to match this sort of thing. Always end with IS because that's just a good habit to have. You can do passphrase equals not ampersand star quote. And I think this might be the solution, so I might just be giving it away. But that's how you match things that are within the passphrase equals parameter. Passphrase equals any number of not ampersand characters followed by a single quote. That way you're not going to match a different field. So passphrase equals any number of not ampersand characters, and then a single quote will not match the annoying request at the bottom. So that's just a hint or a solution, in fact, for this for the first level. So I will do about 10 more minutes. Let's do about 11:15. I will resume. And then the last section is going to be just a lot of bypasses. So let's work for 10 minutes. And then, yeah, good to go. All right, let's do the solutions for the next couple levels for Suricata. Once we're done the Suricata stuff, I have about 20 slides to cover real fast on different ways of bypassing rules, different things to look for and whatnot. I'll go through them quickly and you can use them as reference after. And then I've got 3 sections on bypassing, so I'll give you like 10 minutes, do solutions, 10 minutes, do solutions, 10 minutes, do solutions, and then hopefully it'll be noon and we can all go get lunch. All right, so for the SQL injection level, I think I gave you a solution already. I think the one I wrote will just work. The basic idea is we need to match the passphrase parameter equals not ampersand star quote. Whoops. The thing I didn't do here, actually, there's 2 things I didn't do. I didn't select a buffer, HTTP request body. If you don't pick a buffer, what's going to happen is it matches a whole packet, which is often fine for us. But you can't do a lot of things when you're in a no buffer. It's a TCP packet, non-HTTP packet at that point, and you can't do things like URL decode and stuff. Speaking of, always URL decode in the body. URL decode. Makes no difference here, but it will be important. Next one, SQL injection for search. So this one, we see a parameter. It's the search equals, and then single quote is what we want to match. And the thing I like to tell people is make sure you're matching the vulnerability, which is in this case is single quote escapes the expression, and not the exploit, which is the or 1 equals 1 part. Or 1 equals 1 could be a lot of different things, but the single quote has to be in the vulnerability. Like to exploit this, there has to be a single quote. There's no other option. So that's what you want to match on. So we'll do http.uri content search equals content quote. That will probably hit one of my fake requests. It does. So we're going to do PCRE instead. And then search equals not ampersand star. Yeah. A note to myself is I should do one that requires this and one that doesn't, instead of the same thing twice. But you know, it is what it is. Okay, so that is that. Next level is the shell injection. This one we can match URI if we want. So http.uri content is this http.request body. Now I've said whenever you use request body, be sure to URL decode. That does not apply to JSON. JSON is not URL encoded, so you do not need URL decode for JSON. It doesn't hurt. It won't break anything, but you don't need to. JSON instead can use a \u escaping, which is very annoying, and I will cover that in the bypass section. So let's just do back into PHP. I have an error that I typed something wrong. Oh, I switched that buffer and did not check anything. So we know from the vulnerable code that artifact has to be in there. So let's just do artifact. Artifact. Test the rule. This should work, but match bad payloads, which is perfect. Now I'm going to show you my favorite thing to do, which is matching JSON. So PCRE, let's just do that. SI. S for new lines and I for ignore case. We're going to do, let's see, we need gold or gems or artifacts with a quote on either side. So quote, one of those words, quote, any number of spaces, colon, any number of spaces, another quote, and then not quote, any number, and then the bad character. This is from memory, so let's see if this works. So when I say I hate matching JSON, this is why. Like, this is the best you can really do to match JSON in a fairly accurate way. And what's real fun is if you really, really want to do this right, I'm gonna get the hex for hex dump dash C. G can be encoded as \U \U0067, and you have to do that for every single character to really match JSON. And no one's ever gonna do that, but that is the only way to really match JSON, which drives me absolutely bonkers that doesn't decode it for you. But yeah, that is that. That's a big hint, by the way, because that's going to be a way to bypass all my serial rules. All right, so the last one is the XXE. You don't have to do this, but you can do http.content type content, because like the more accurate you can be, the better for many reasons. It's faster, it's less false positives. Multipart / form data. Yeah, you don't have to match the content type. I like to. And then we're just gonna match this string because I think that's a pretty unique string. HTTP request body spelled wrong. I'll fix it after. Content blah. Now fix all my typos. Make the typos worse. Is it lunchtime yet? All right. I think that will work. Uh-oh, missed an evil payload. What did I do wrong? HTTP request body, content entity. Nope. All right, look at my cheat notes. When I find myself in a situation, like when I'm writing a rule, I will delete each part of it and figure out which part is missing. So that did not, oh. Header? Yeah. Let's just delete that section. There we go. That works. Good enough. I don't know why the header is failing. Did I spell multipart / form dash data? Multipart. Thank you. I was spelling it the French way. Wait, I can't make the excuse. All right, perfect. All right, and then the last section. Well, I broke it into 3 sections just so we could do some work, some solutions, some work, some solutions. I'm gonna write down this 1023. All right. So now I'm gonna do bypassing. These are no particular order. I basically wrote my own notes. This is my notes app. I wrote like a million things that can bypass rules, and I tried to take all this stuff and throw it all into like 20 slides. So this is gonna be bang, bang, bang. I've tried to talk about how bypasses work as I've been talking about the rules. So some of this will be review from stuff I've already like talked about. In this section, this is sort of a like making fun of AI in a way, because who doesn't like making fun of AI? Each of these sections ends with a AI-based rule, where I'd asked AI, can you write a rule to detect this exploit? And it wrote a rule. In general, the rules are more complicated and easier to bypass. So lose-lose. I'm sure you can give better prompt. I just wanted to like give you something to like play with. So like each of these sections has like a couple that I wrote and then AI rule. So those can be fun. Maybe they're annoying. I don't know. You can skip them if you want. So shell injection. Earlier when we did shell injection, we checked for semicolons, pipes, and backticks, I think. Don't forget there's lots and lots of ways to inject with shell injection. New lines are like a skeleton key that almost everyone forgets, including me. So look for those. Get versus post arguments. So a lot of the levels, not all of them, but some of the levels I wrote exploitation. A lot of them will work if you take the request and make a get parameter instead and make a get request. So that is a way to bypass a bunch of stuff, is to like change from a get to a post. This one did not work, but, or did it? Yeah, it failed. So like that will sometimes work, sometimes not. So that is a thing to try. Get versus post. URL encoding. If you ever see raw and you don't see URL decode, that's a problem. If you ever see raw and you see a URL, try adding /./ in the URL, because most URLs, where'd the game go? Most URLs you could do like, you can add dots to the URL and it will be the same thing. In http.uri, it will fix that. In uri.raw, it will not. So if you need to bypass like pass reversal param, you can do /./ and that might work. Back to my slides. Yeah, the raw is really, really hard to use correctly. So if you see raw, look for ways to bypass raw. Ordering of things, A equals B and C equals D can be C equals D, A equals B in parameters. Headers can be rearranged, JSON fields can be rearranged, stuff like that. There's lots of different things that could be reordered if that's a thing. Lots of fields in XML are freeform. The tags, tags in angle brackets can always be tag A equals B, C equals D. You can add tons of crap inside. Also new lines. Speaking of new lines, spacing. If you can do one space, you can often do multiple spaces. That goes for a lot of different things. JSON, XML, headers, stuff like that. The HTTP.header will fix certain spaces. HTTP header raw will not. So watch out for that. New lines. Regexes by default don't match new lines. The S means do match new lines. So if you don't see the /S, add new lines. JSON can be mangled like crazy. I was talking about this earlier. A:B can be new line A, new line colon, new line B. So if you're matching colon space quote, you're gonna miss things. Also, that bottom thing /U0061 can bypass almost every rule. I think all my rules can be bypassed with Unicode encoding. So feel free to like just bypass all the challenges with one. I'll also say like each of my bypasses have one intended solution, but they're all going to have lots of unintended solutions. So figure out what works for you and just do it. Base 64, I love this. I don't know if this is well known, but when you encode in base 64, every 5 bits of your original string becomes 8 bits of base 64, which means if your string is like 3 bytes long, 3 bytes is 24 bits, which means it will encode the first 5, then 5, then 5, then 5, and it has 4 left. That means that the last 4 bits are encoded into 5 bits, which means the last one's ignored. So in this case, somewhere between 1 and 4 bits, somewhere between 0 and 4 bits at the end of a base 64 string are just completely discarded and ignored. So you can often change base 64 a little bit like that. You add 1 to the last bit, and it will almost always work. I really want to fork the base 64 tool to always use the least likely encoding, because when you encode base 64, it zeroes out the bits. If you instead make them 1, then you will bypass anything that matches base 64, which I think is really cool. The base 64 decode function shortcut is really hard to use correctly. So if you see that, look for ways to bypass it. Paths I mentioned can be all kinds of crazy things. If you dot doesn't work, try dot // that will also work. SQL queries, basically look for how the SQL query is supposed to work and how you can like do different ways. You don't always need spaces. The word or is optional. You can often use like different ways of doing queries. And the general advice, I know I went through real fast, so use these slides for reference. But the general advice is figure out how the vulnerability is supposed to work. Is it a single quote? Is it being passed into a shell? And then try to find other ways to do that. Can you add characters? Can you add spaces? Can you add new lines? Can you rearrange things? Like, I already said this too. I have intended solutions, but you'll find new stuff. If you think you found a really cool solution I don't even mention, hit me up afterwards and like tell me. So the way this will work, if I could find the right window, is each of these will have a bunch of different bypasses. I'll give you the rule. You're gonna have to like look at the rule and go, oh, this is matching the request body with a regex of IP equals not ampersand star semicolon pipe ampersand backtick dollar bracket. How can I exploit this without using a semicolon? And you're gonna do this for everyone. And I think this one is just a new line, is one way to do it. There's lots of ways, but that didn't work. But you'll find lots of ways. You'll find different ways of doing different challenges. So like, I will cover my solutions, but yeah. What else? Yeah, I think that's pretty much it. You can go off and work. I'll do about 10 minutes of working, couple minutes of solutions, 10 minutes of working, couple minutes of solutions. We might go a little bit past 12. So if anybody has a hard deadline of 12, let me know and I can go faster. Otherwise, we'll probably push the deadline a little bit. Yeah, we'll come back in 10 minutes and do the first few solutions. And feel free to work ahead and do all of them if you want. There is a lot. I think I skipped this slide, but don't forget URL encoding as well. A can become %41 and such. That's also pretty important. And importantly, %26 is ampersand, and those are hard to distinguish. Three 10-minute sections are just. All right, let's do solutions for part one. I don't want to go too late. So, like I said, I have intended solutions, and there are lots of unintended solutions. The one I was trying to say earlier was percent %OA, new line. That will work, but that's not the intended solution. The intended one here was to abuse the fact that a ampersand can be both an injection character and also a ordinary character. So if you stick an ampersand in here, it's not going to work because it's going to interpret it as a different argument. Also, it's going to catch it apparently. If you do percent %26, however, and then call it ampersand, that will work because this, as far as the server knows, this is all one argument, but Suricata thinks that the argument ends right here because it thinks it's an ampersand. So that is that level. Let's see. On the wrong page of my notes. I'm using my notes here because I don't want to give you the wrong solution since it's a lot of ways. So this one, number 2, we did not do URL decode in this. So if you encode the character as matching, for example, the semicolon, semicolons become %3b. That will work. And there you go. Level 3, this is the one where the new lines was my intent. I have a pretty complete set of everything, and I just knows I'm not doing URL decode here, so I think %3b would also work. Whoops. Does that work? Yep. But what I meant to do in this one was new lines, 0A. Both works. And then part 4, this one blocks the word cat, which is not a very good rule, but it does make you use a different way of printing that file. So there's lots of ways you can do it. One is to copy the file to dev std out, which is neat. There's a lot of neat tricks you can do to like print a file without using cat. I love copying the dev standard out. I think that's pretty cool. I think you also do /proc/self/fd/1. I love these little tricks for like bypassing filters. And then the AI one, this one does not do URL decode as well. So turns out %3b works for like half of my challenges. Whoops. So that will also work. Which takes us to the URL-based path traversal. First one uses URI raw. As I mentioned, if you do URI raw and don't use URL decode, you can bypass with like %2e or lots of other options. So let's do that. Paste, 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 paste. Send. There you go. Level 2. This one /dot is what's matching. So if you do double slashes, it's still a valid path, but you never have /dot anywhere in the request. So there you go. See. Oh, looking at the wrong note. This one checks for %2e, but it does not do case insensitive. So you can do %2e uppercase, %2e, and then %2f. Copy, paste, 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 paste. Send. There you go. And the AI one, for whatever reason, decided to look for app server in URI raw. And looking for a specific string in URI raw is going to be very easy to bypass. Just change A to %61. There you go. URL encoding is often the problem. All right, default login. This one uses HTTP header raw. When the HTTP headers are normalized, the colon space becomes a single space. When they're raw, it does not. So you can just add more spaces. Next level. Oh yeah, this one, it uses HTTP header now, which means adding spaces won't work anymore because it gets normalized. However, it does a case sensitive match. So if you do basic to basic, that will work. There you go. And then part 3. This will work for all the parts, but I talked about ambiguous base 64, changed 4 to 5. It's still admin. There you go. Default login 4. I used base 64 decode, which as I mentioned is kind of complicated. This one uses offset 0 relative, which means it starts decoding immediately after the match, which is basic space. If you do basic space, 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 it will still work. Or not. Basic space, space. There you go. I don't know why more space is broke, but whatever. Add an extra space and it will work. And then the AI one, let's see. I just use the ambiguous base 64 thing again. 4 to 5. It did not use HTTP or it did not use base 64 decode, which is not surprising, but there you go. Is that the end of part 1? That is the end of part 1. So I will let's do like 8 minutes. I know this is not much time, but I'll give you to 54 after, and then we will do the solutions for next part. All right. I know that wasn't too much time, but we have to keep going if I want to be finished on time. So I'll do the next few solutions for the part two. First one, the issue is question mark file equals, which can be bypassed with a equals b and file equals, because you can add all the parameters you want and they just get ignored. Uh-oh. What did I do wrong? Picture PHP. Oh, file equals a, wait. Yeah, I typed in the wrong place. Question mark a equals b ampersand. There we go. And that's that. Next one, I checked the URI, but this will work as a post. So I'm going to copy the payload, make this a post, and paste it here. And that should work. Nope. Fairly bad this today. Uh, Not found. Wait. What did I do here? I made a mess. Picture PHP question mark file equals. Oh, I didn't copy the whole thing. That's why. This is what happens when you rush. All right. Post, and then paste, and then send. Well, did I miss the space? Good enough. The idea is you go from a get to a post. I don't want to dwell on this while I'm question mark. That shouldn't matter. Question mark should be okay. I don't know. That's okay. Uh, yeah, I don't want to dwell on mistakes, but that's the idea anyway. Third one does not have URL decode. This is what should have been the previous one. I don't know why it didn't work, but anyway. Uh, this one's not URL decoding, so %2e, %2e, %2f. Copy, paste, send. There you go. Next one. This is a normalization thing again. Dot dot slash dot dot. You can do dot dot slash slash dot dot. And that should work. Boom. Part 5. This is once again a case sensitive thing. So %2e, %2e, %2f. Paste, 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 paste. Send. Export is unsuccessful. I'm having no luck with my oh, is this? No. Anyway, the idea is this is not case sensitive, and it is you need to do case sensitive, so that is how you're supposed to solve it. And then the final one, once again, this is AI. Once again, it did UI raw. So if you can encode one character in the raw URL, like the F, you should be set. So the F becomes %66. So %66. I think I told the AI that like if you're doing a path traversal, you have to use raw, and it thought you had to do path traversal for everything in raw. That might be what happened there. I'm not sure, but it did a bad thing. All right, first SQL injection. Um, this one also has URL encoding problem. If you encode the quotes as %27, you can bypass this. This is like the classic problem with post requests, is that you can do %27 and such. Second one, this matches passphrase equals quote, but you can do passphrase equals ABC quote, and it will work just fine. So that's that one. Number 3, this has the ampersand problem I mentioned before. This is a really hard problem to solve, honestly. Because of ampersands being a separator and also an injection character, you can almost always use them to like kind of break out of a make Circuit think you're breaking out of a parameter where you're actually not. It's really annoying. I really wish there was a way to deal with that. The next one, number 4, is avoid spaces. I mentioned spaces are optional, so you can just not have spaces and it'll still work. There you go. Part 5, the or match is case sensitive, so you can do capital or, and it will work. There you go. Number 6, this is a PCRE with no S on the end, which means new lines will break out of the PCRE. So %0A will break the query, and then this does not match a new line. And then the AI one decided to match 1 equals 1 explicitly. So I just did 2 equals 2. And there you go. Let's see. This is still part 2. Okay, this is part 3. I know it's noon, so if you gotta go, you can go. But let's just do 5 minutes of working, and I'll do solutions. And I apologize for running into the end of the clock because this was a lot. So 5 minutes of work. 12:05. We'll do the rest. And also, if you gotta go, here's my contact info. That's my email address, and my handle is YagoXA6. Feel free to reach out. If you like or didn't like something about this, let me know. Always happy to hear your comments. Running out of time is they don't like, so I'm aware of that one. Yeah, about 10 minutes.